Hello, today I will be talking about constant motion and how Newton's second law is used to predict the position of an object that is experiencing constant motion. First of all, in order to understand how constant motion works, we need to understand the basic concepts involved in Newton's second law, which is Vf equals Vo plus F net over mass times delta t, as shown on the screen. Also, we need to know that the change in velocity is the change in position over change in time, or delta x over delta t. And in order to obtain constant velocity, we need to understand that final velocity needs to equal the initial velocity, which means that, first of all, the F net needs to be equal to zero. And this means that the sum of all the forces acting on the object need to be equal to zero. And also that the overall velocity cannot be equal to zero in order for there to exist motion. To prove this, I conducted an experiment where I rolled a volleyball on the ground in a straight line for it to be uninterrupted and for its motion to be as close as it can to being constant. After recording this, the video was set on Tracker, and I used a coordinate system where the x-axis, as can be shown in the screen, was where the ball was rolling, representing its change in position. The change in time was also recorded. Later, these two components were used to build the computational model on VIDLE for VPython. This model represents the theoretical movement the ball must have had if the motion was completely constant. Later, the data from Tracker and the model were acquired and set in one spreadsheet in order to obtain this graph. As you can see, the blue line represents the experimental position, which is the data obtained from the tracker, and the red line represents the model's position, which is the data obtained from VIDLE. In my chart, you can easily observe the disparity between the model and the experimental data. Usually, in these types of experiments, the model position line should be higher than the experimental position. That means that the red line should be on top of the blue line. This is because in the experiment, the object experiences forces, such as gravity and friction, that are not accounted by VIDLE. But in my case, the experimental position line is higher than the model position line. This could have been caused because of the fact that the data obtained in Tracker was done by human eye, which leaves a margin of error, and therefore the initial velocity obtained by the first displacement points of Tracker might not have equaled the velocity for the rest of the track experiment. Addressing the what-if problem stated on the screen, if the coordinate system were to be changed when the axes were flipped, the only major difference would be that the model and experimental lines would be inverted, and the slopes would also change. In conclusion, Newton's second law of motion effectively predicts the change in position of an object in time when the net forces acting on it are equal to zero. Also, that in order for there to exist constant motion, the sum of these forces experienced by an object need to be equal to zero. And all this was proved by the experiment done with the volleyball, and that this experiment, even though it had some disparities, does confirm the law of constant motion.